Hey everybody, welcome to the shop this week. Today I'm going to talk about a really unique material that eliminates a lot of problems in woodworking, and that is a warped panel. How do we keep a panel flat after we glue it up? Half the time you do that, if you move too fast, the wood's not acclimated, it ends up like a potato chip. So using a very unique material, cardboard, resin impregnated cardboard, I am going to create a panel that stays dead flat, is totally lightweight and super durable. So let me show you what that is. This panel is a cutaway version of what I like to build when I build conference tables or a big panel that's unsupported or something that I really need to reduce the weight. It consists of a cardboard core, a skin of some form, MDF or Baltic birch plywood. You could even use a poplar skin, and then a final layer of veneer. So the veneer is shop sawn, meaning I can create whatever kind of look I want. I can create whatever thickness I want. That still allows for the wood movement and the veneer form. But in the end, you create a very rigid panel that's 50% at least less weight than a traditional panel glue up. It's a very unique material and process, but it does require some specialty tools like a vacuum press. And we're gonna walk through the steps today and show you what this thing is and how I do that. So one of the very unique things about it is you can use shop sawn veneer. So taking a board, a dimensional board, running it through the bandsaw. In this case, I cut it to about 3/16 inch thick, and I'm able to get a very thick piece of wood milled down in multiple pieces to where I can create veneer. So I will run that through the planer on a sled, or run that through the sander, and I end up with a final thickness. I'm shooting for about an 1/8 inch at the very end of the process. I want the 1/8 inch thick veneer. So that kind of eliminates some of the wood expansion and contraction problems that you have in solid panels, but still offers an extremely durable surface to where you could sand that thing 50 times and you're not going to sand through. You can gouge it, fix it, and it's not the traditional paper thin veneer that you see a lot of times, and it becomes a very usable surface. So that is the key component. We take our veneer, we glue it up into a panel, as you see here. And then once this panel is glued, I run it through the sander, and I want to get it flat. So I still have a little more work to go on this panel in particular, but I'll sand this, and this is the skin, the outside skin of one of the panels that I'm building. The cardboard core, again, is a honeycomb pattern. This honeycomb pattern, when you apply a skin on one side and a skin on the other with glue, that prevents any movement on this panel. So you see that it's flexible now, but as you attach a panel on each side, that becomes what they call a torsion box. So in every direction, there's tension on the skins that don't really allow it to flex or warp or anything like that once the glue is cured. So it's a very unique and durable process that keeps the panel extremely flat. So in plywood, you have to have multiple layers, plies of a material in order to get this stable panel. So how do you do that? The very first step is you need a core, and that's where we're going to use our honeycomb core. Then you need a skin on the outside, which creates the torsion box effect. And then you need, when you're using veneer, you actually need a crossband, which a crossband means the grain is going in an opposite direction of the final grain. So I have a poplar skin under here that is going in this direction, and then my final veneer is going in this direction. If you add up all these layers on both sides, there's an odd number, and that odd number is critical, meaning you have a balance on each side of the core, and that creates a balanced panel. That balanced panel stays flat because everything that's happening on one side of the board is exactly the same that's happening on the other side of the board. So that's a critical thing when you build a panel like this, is you have to balance the panel. Even in traditional veneering, you have to balance it. So what I'm gonna do is actually use Baltic birch plywood, and that Baltic birch plywood that I'm gonna use is 3 millimeters thick. So 3 millimeter thick plywood has 3 layers that are 1 millimeter each. Each one of those alternates, meaning when my final veneer goes on here, I have created this cross-banded effect, and my final veneer can go right over top of this plywood. So let's take a look at the steps and how we get from all these rough components to the final product, which I'm going to use as a butterfly leaf extension in a table. So it's going to open up and be stored in the table. But I want that thing to stay flat so that when it is opened up and actually used, it's flat enough for the whole assembly to lock back down onto that panel and keep it flat without any kind of effort or flexing into position. You don't want that. So let's take a look and I'll show you the process. All right, I've got my glue mixed up, and I'm gonna be applying it with a roller because that's gonna give me a very even distribution on the panels. I'm also going to be using a resin-based glue, which when it hardens and cures chemically, it is a very rigid glue. So it doesn't allow it to flex, it doesn't allow it to expand and contract. It really holds the panel well. And that glue is kind of critical in veneering in this process. All right, so let's talk about that process and what you saw that I did and what I regret that I did, because when the glue comes out, you get dumb. So first things first, I didn't mix enough glue. I ran out on the third panel. I calculated using math, but guess what? I didn't give myself enough extra and I ran out. I had to mix more glue in the middle of a glue up, and this glue takes 5 minutes to mix. So I was screwed up, rushing, and I still was able to get it done because the glue has a massive open time. However, be prepared for that. First mistake. Second mistake that you saw was I slipped these in, and I was gonna use a caul sheet over top of everything with a hardboard, and then put my mesh, breather mesh over top of that so that that whole panel could suck down. Well, guess what? It's oversized from the pieces that I'm pressing, so the ends would have collapsed under the weight of the vacuum, and it would have just smashed it, bowed it, everything. It wouldn't have worked. So you saw me pull that hardboard out and put the breather mesh directly on top of the panel. So I don't know what I was thinking there. The next one is just be prepared. In a glue up with a vacuum bag, sealing it up with that strip, that closer strip, that's a challenge. And when you're rushing the clock and you're already behind because you didn't mix enough glue, it starts to get really complicated in closing that thing up and getting a vacuum. So I'm going to talk about the vacuum that's currently running, and that is not a full vacuum. If I was to use a full vacuum prior to this step, that cardboard would collapse under the vacuum. So it would pull all the air out, crushing the cardboard between those two panels. We obviously don't want that to happen, so I'm doing a half vacuum right now on this layer. I will trim these panels up. I'm going to edge them in hardwood, and then I'm going to put the veneer on. When I do all of that, the next time in the vacuum bag is going to be full pressure, and that will not, because of the torsion box effect, will not collapse under the vacuum weight. So that shows you how strong this honeycomb core is. It can survive a full vacuum. So let's keep going on the process, and I'll show you step by step moving forward. So step one is complete. We have pulled the vacuum. That was only halfway done. Just enough pressure to keep the pieces flat. I will clean up all this tape. I'm gonna trim this to final dimensions, and the final dimension is the inside of this wooden walnut frame. So I've milled this thickness of the walnut to be matching the thickness of this core panel with the skins. So I'm going to cut this to the right size, put it inside, lay my glue on the walnut veneer top and bottom pieces, sandwich this thing together, full vacuum for 4 hours, pull it out, sticker it so it dries evenly on both sides, and then trim to final size. So most of this walnut you'll see here is gonna go away. I'm gonna have about a 1/2 inch thick strip all the way around, and that is kind of my solution to getting a good wood edge with the veneer going all the way to the edges, where you can shape it, put a profile on it, still have walnut, and not have to use edge banding or something like that to finish off the panel. So on the table, you're only going to see this edge on the outside, and that is definitely the goal moving forward, is kind of the grain look without weird layered veneer look on the side, things like that. So I want the hardwood edge to be as much of what you see as possible. So that's the next step. You'll see I'll clean this up, and we'll go through that glue up. I've got my panels all fit inside the frame. I have matched the thickness of this panel and the thickness of this frame with a drum sander, running it through until the thickness matched up with calipers. So this is a flush joint, top and bottom. The next step is gonna be locking that into position by rolling glue on these panels. I'm gonna set the core on it, take the top, roll glue on it, set it on it, tape it just like we did with the skins, load it in, and vacuum it. So with a full vacuum, I picked the worst faces for the bottom of the panel. You have to balance the panel so that it stays flat on top and bottom, because whatever you do in veneering on one side, you have to do to the other side to have a balanced panel. That's going to keep it flat, keep any of the movement exactly the same, top and bottom. But I want my faces to be nice, clean boards in a rustic grade walnut that look nice and match the tabletop when we go to install them. So you see things like knots and all of that, which I don't really mind on the bottom. If I would have had material for it, it would have been fine to use better material, but you're never going to see that except for unfolding the panel. So literally just to balance it. So that is where we are. So let's take a look. The glue is about to be ready, and then we're gonna roll it on, put it together. Everything's in the bag. I've got a full draw on the vacuum, and we're gonna let this go for about 5 hours. The glue is 4 to 6 hour clamp time. So 5.5 hours. I'm gonna start touching glue that I have on a stick just to see how dry or cured it feels. And if it feels cured, I'm going to pull it today, sticker these so they sit with airflow on both sides, which is little sticks under each panel. If it doesn't work, if it's not fully dry, I'm gonna keep letting it go, and it'll probably go for a handful more hours, and I will just have to shut it off once that glue feels like it is rock solid. I don't want to release the vacuum early, so this glue has an advantage of a long open time, but it also has to be clamped for a long time to set. So next steps will be pull it, sand it flat on top and bottom, and trim to final size. So that's the fun part, where we get to see all the work come together in these really cool panels. All right, so as you can see, I pulled the panels out of the bag, and next up is going to be taking off everything, sanding this flat, because I only sanded one side of the glue up to give me the most thickness possible without wasting material. So now that these are adhered, I'm going to run them through my sander, top and bottom, clean them up, trim off this glued edge where the veneer overlaps the hardwood, and trim it to final dimensions. So that'll be next. Hinges installed so that this can function as a butterfly leaf on the table, and I'll show you the end result in the table, just showing that you can build this veneered panel super lightweight, but it still feels dense, sounds like wood, doesn't sound hollow, and all the benefits of that. The fact that this is going to stay flat, unsupported, is great. So hope you enjoyed that process. Let me show you a few more details, and then we can go from there. Trimmed the edges with a flush trim bit on one side. All that's going to do is establish a reference edge that I can run against the table saw fence. So I'll run that on the fence, cut this side, flip it over, cut this side, and then go with a cross-cut sled for the ends to final dimensions. Very easy to clean that up, and then the table saw will do the final dimensioning. So on this table, I have my pieces laid out, and I'm going to use hinges to create this butterfly effect with these panels. But I wanted to point out a couple things, and that is with the veneer, it's going to come all the way over the edge, over the hardwood edging that I applied with the frame, and you're going to see that line. However, I wanted to show, just by putting a little bit of alcohol on the wood to show the grain, when you do that, that line is visible. However, when you put a round over on or shape this profile, because I have hardwood under here, I can put a different profile on there. Once I do that, that line really disappears very well. And for this application on the leaves where it's rarely seen, I totally will accept that as the compromise of having a flat panel that maintains its shape with no support. So real world application for the panels is in this table that opens up 3 feet, and the leaves that we built store inside the table on a butterfly hinge. So that allows me to fold it and store with no supports in the way. And that is one of the advantages in a real world application of why you would want to use that cardboard panel. So as I fold these leaves out and close the table up, this all becomes one unit. It's flat, it's stable, and it allows me to open and close it, even though unsupported for months at a time potentially, where those panels will not warp. Another cool thing is this is the sound of the cardboard core knocking on it, and this is the sound of solid wood. It is pretty unnoticeable that this is a cardboard core versus a solid wood panel on the normal orientation of the table. So lightweight, I can reach across and grab this entire panel. Lightweight because I need this hinge to be able to support the weight of these pieces. all of this together weighs essentially the same as one of these solid panels, and that would just be a lot to ask for this hardware and not bow or be hard to move and maneuver. So that's kind of the practical application of why I build those honeycomb core panels.